In this class, we will discuss about the numerical differentiation. And here we will be considering the Newton's forward difference polynomials to differentiate numerically a given set of data. Okay. So let us consider this. This is the given set of values of x and y. Here we are having xi comma yi. So these are the given set of values for x and y. Okay, and in this particular set of values we have to apply this Newton's forward difference method to get the interpolating function, and that function we have to differentiate. Okay, so here we have only a set of data, a set of points that is provided. We don't have any function to differentiate, so first we have to interpolate that set of data, and then we have to differentiate that particular interpolating function. And these are the points that are given xi comma yi, and I runs from 0 to n. Okay, so from this set of values we have to find out dy by dx at any point in this range of x values. Similarly, d square y by dx square, etc. Okay, and this particular technique is called as numerical differentiation. So basically, we are having set of points, and from that set of points, we have to find the differentiation of that particular function. So that function we had to find out through the interpolation technique. Now, how we can do this? There are two steps, as I discussed. First, we have to find out the convenient interpolating function for the given set of data. So first we have to use any interpolation technique. Here we are considering Newton's forward differential difference polynomial. So that particular technique we are using, so that we will get corresponding polynomials, and we'll get corresponding function for this particular given data points. Okay, so first we have to use the convenient interpolating function or that technique that will give you some particular interpolating function, and then after getting that particular function, then we have to differentiate that particular function, interpolating function. Okay, that is the step that we have to follow. So if you are considering different interpolation technique, we have different interpolation techniques. So if you use any of those techniques, the corresponding differentiation also will be different. Okay, so for different interpolation technique, we use to get the interpolating function. Okay, different interpolation technique we use to get the interpolation function. We derive different formula for the derivatives. So by using, if you are using different interpolation technique, in here we are using Newton's difference method. So if you are using some other interpolating technique, then we have to go for some different equations for differentiation. Okay, so for each interpolation technique, we will be having different equation for these derivatives dy by dx. Okay, so this equation will change. That will depends on which kind of interpolation technique that you are using to get this interpolating function for the given set of data. Okay, now if you consider this Newton's forward difference interpolating polynomials, then the equation is like this: y equal to y0. This one we already discussed. Okay, so y equal to y0 u into, in that case I think we have a p here, so that you can change. So u into delta y0 plus u into u minus 1 by 2 factorial del square y0 delta square y0 plus u into u minus 1 u minus 2 by 3 factorial delta cube y0 plus etc. so on. Okay, so this is the equation for that particular interpolating polynomial. This is the equation for interpolating polynomial. Now, where as you can see, x equal to x0 plus uh, I think in the last section we have considered, when we discussed about this Newton's interpolation technique, we have used p instead of u, so that you can interchange, no problem with that. So x equal to x0 plus here, and u equal to x minus x0 by h. Okay, and now we can consider dy by dx here. Dy by dx equal to dy by du into du by dx. We can write it like this. So this du get cancelled and dy by dx will come. Okay, so this is dy by dx is nothing but dy by du into du by dx. So that du by dx, you can see du by dx is nothing but 1 by h. You just differentiate this one. So if you are taking du by dx here, this term is constant, then this term is going to be differentiated, so that will become 1, so 1 by h will come. So du by dx will become 1 by h. That's what we have written here. So this term is 1 by h. So that I have written here, 1 by h times, then we have to calculate what is dy by du. So for that, we have to differentiate this particular equation with respect to u. Okay, so first term, this y0, that term will become 0 because it's a constant. So it is independent of u. So that will become 0. Second term, this u will become 1. This u will become 1. And only delta y0 will exist. That's what we have written here. And this third term, u into u, that is u square. So if you differentiate that one, it will come 2u. Okay, minus 1. So minus 1 means this u had to be multiplied here. So it is minus u. So if you differentiate that, it will come as minus 1 here, divided by 2 factorial, that is 2. Okay, into delta square y0. Similarly, if you differentiate this term and other terms, fourth order term, all other terms, if you differentiate, then you will get equation like this for your dy by dx. Okay, so this is the equation corresponding to the differentiation of given set of values or data that is given. So let us consider this a particular equation, and you can see this is applicable to any points, any arbitrary points you can find out. For example, if you have given set of values from x equal to some 0 to 5, so it can be varying from 0, 1, 2, 3, 4, 5. So in this range, you can give any value. For example, 0.1, 0.2, 0.3, any value you can give, or 4.1. Corresponding dy by dx you can calculate by using this particular equation. Okay, that is for any point. Okay, and if you, so this is a little complicated, not complicated, but something lengthy equation. But if you restrict that to the tabulated points, which means that the points that is given to you. Okay, for example, if you are given 0, 1, 2, 3, 4, 5 for x values, and if you want to find out what is dy by dx of this particular data points at 2, so this is a tabulated point which is available in your data set. Okay, so for that case, for example, if you consider x equal to x0, at x equal to x0, I want to find out what is dy by dx. In that case, at x equal to x0, our u value will become 0 because u equal to x minus x0 by h. So when x will become x0, so this, when this will become x0, you will be getting 0. So your u will become 0 at x equal to x0 at this tabulated point. This is nothing but the first point in your x data, x values. Okay, so at that point, if you want to find out what is dy by dx, then you can use this equation, so that your equation will be reduced. It is going to become simple. A little these terms, u terms will become 0. This term will become 0, and this term will become 0. Okay, so all these terms will become 0. I think not all those. This term, this 3 square minus 6u, this 2u, and this 6u cube up to this term, all these terms will become 0. Only the constants will exist. Okay, so then your equation will be reduced into this form for at x equal to x0 for the first data point. And similarly, you can find out what is for x equal to x1, which means that x minus x0 is still h, and then u will become x minus x0 by h. What is x minus x0? X minus x0 will become h because you are considering x as your x1. That is the first point. Okay, so x1 minus x0 is the step size, that is the separation between each points in the given data set of x values. So x minus x0 will become h in this case because you are considering x as x1. So it will become x1 minus x0, that is the second x value minus first x value. That is nothing but your h value. That will give you h by h, that is equal to 1. Now your u will become 1, and if you substitute that in this particular equation, then you will get dy by dx for x equal to x1, that is this tabulated point, that is for first point, as like this. Okay, so this is the second case, and similarly you can consider x equal to x2, x equal to x3, all those points, that is for tabulated points. Okay, so in general you can apply this equation for any uh, points. Okay. Now for second derivative, what you have to do for second derivative, d square y by dx square. So second derivative I can write it like this, that is nothing but d by, this is dy by dx, so d by du of du by dx, this du and this du will get cancelled, so d by dx of dy by dx will come. So this is nothing but d square y by dx square, the same equation. This I can write it as d by dx of du by dx, sorry, d by dx of dy by dx. So this is same as what we have written here. Okay, this d by dx, this d by dx I can write as d by du times du by dx. Okay, so that's what we have written here. So that is same. And as you know, this dy by dx, we know what is this dy by dx, and du by dx, what is this value? Du by dx is nothing but 1 by h. Okay, so that 1 by h I have taken outside, so 1 by h into 1 by h will become 1 by h square. Okay, and I have to take d by du of the first dy by dx equation. So you have to take d by du of this particular equation. Let's say this is equation number 1. So this equation number 1 you have to differentiate with respect to u one more time. Okay, then you will get d by du of dy by dx, that you have to substitute, and finally you will get equation like this: d square y by dx square will be equal to 1 by h square times del square y0 6u minus 6 by 6. So this is next to that differentiation of u. Okay, so this term is actually, this term is d by du of, what is this term? I think it is, let me see that. So this term is 2u minus 1 by 2, right? 2u minus 1 by 2. So that term you have to, okay, sorry, not that one. So if you consider that term, second term, then I think it should be the first one. Because first term is constant, delta y0 will come, that is constant. So if you take the derivative, that will become 0, and del square y0 you have to consider. So in that case, this I will show you here. You can see in the first equation for dy by dx, we are having delta y0 at first. Okay, so this delta y0 will become 0 directly when you take d by du of this term. So this will become 0, and this term exists, and you will get this differentiation of this one will come as this term will become 0, this term it is 1, so 2 by 2 is will become 1, so only this delta square y0 will exist. And for this term, it will be coming as 6u, 2 into 3 into u. So 6u minus 6u, the differentiation of this 6u with respect to u will become 6. Okay, so 6u minus 6 by 6 will come. So that is the next term. You can see that in here. So in the same way, you have to differentiate all those u terms, and you will get this kind of equation. Then you can easily calculate what is the d square y by dx square value for any point in the within the given data set. Okay, so for tabulated points, similarly you can consider at x equal to x0 your u will become 0, and d square y by dx square at x equal to x0, you can find out this like this. Okay, this is same. You can just take dy by du of the du by sorry d by du of dy by dx, that is we calculated for x equal to x0 point in the case of tabulated points. Okay, so that is it. So then you will get this equation for tabulated case for points which is available in the table directly. For that case, you can use this. In general, you can use this particular equation to find out the differentiation second derivative of the given function. Okay, at any point. Okay, so let us consider an example. Calculate the first derivative of the given function or set of values. You can consider this as set of values below at the point 1.2. So at 1.2, we have to find out what is dy by dx. The given values are x and y. It is given here. So 1, 2, 3, 4, and 5 are the x values. 0, 1, 5, 6, 8 are the y values. So first we have to consider these x and y values. Take the difference between these two values, this x and y, sorry, this y values. So between these two, we'll get y1 minus y0 as 1, 1 minus 0. And this one is 5 minus 1 is 4. Then 6 minus 5 is 1. 8 minus 6 is 2. This we have done for the interpolation technique also. And then separation between these two, difference between these two, 4 minus 1 is 3. The difference between these two, 1 minus 3 is minus, 1 minus 4 is minus 3, and 1, 2 minus 1 is 1. And the difference between these two will give you minus 6, minus 3 minus 3, so that is minus 6, and then 1 minus minus 3, that is 4. 1 minus minus will become 1 plus 3. And then the difference between these two will give you 4 minus minus 6, that is 10. 4 plus 10. Sorry, 4 plus 6, it is 10. So these are the values corresponding to the deltas. As you can see, delta y0, del square. So which value we have to consider here? Delta y0. These are the delta y0. This normally this is delta y. Okay, delta y, del square y, del cube y, all those values, and this will give you the corresponding y0 values. So delta y0 is this one. Delta square y0 is 3. Delta cube y0 is minus 6. Delta raised to 4 y0 is 10. So these values we have to substitute in equation to find out what is the differentiation of the given for the function which can be interpreted for this particular uh, set of values at this point. Differentiation at this point, 1 point. So let us consider that. So in that case, now if you substitute that in the equation, then you will get it like this. You can see f dash of x. This is f dash of x. F dash of x is equal to dy by dx, and that is equal to 1 by h times delta y0. This is the same equation, that is equation number 1 that we have written for the general case, and put x equal to 1.2. That is what the differentiation we have to find out for this particular point, x equal to 1.2, and h is x1 minus x0. So that is 1 minus 0 in the given data point, you can consider, and that will become 1. I think we have given x values as 1, 2, 3, 4, like that, right? So it will become 2 minus 1, and it is 1. Anyway, h is equal to 1. So h is nothing but x1 minus x0. This is in the given data set, it is 2 minus 1. So that will give you this one for h value, step size. Or we can consider it as the interval, okay, in that x, the given x points. And this is u is nothing but x minus x0 divided by h. So what is x? X is 1.2 here. That is the value that we have to at which we have to calculate the dy by dx. So that is x. X is equal to 1.2. So 1.2 minus 1 divided by 1. 1 is h. So that will give you 0.2 as your u value. Okay, and you substitute those value in this equation for u, and you already know what is del square y delta y0, delta square y0, delta cube by 0, all those values you know, and you substitute that values here, and then you can find out the equation. You are having 1 by h also here. So then finally you will get minus 1.7733 for your as your answer. Okay. So how we can write the algorithm for this particular uh, differentiation method, numerical differentiation method. So this algorithm is for tabulated point at x equal to x0. You can modify that according to the general case also. So this I have written as a simple case. So at x equal to x0, we are considering. So this is for tabulated case. So in that case, we have to consider the minimized form of that general equation that we already discussed for x equal to x0, how the equation comes. Okay. So in that case, it is, I think it is better I will write that particular equation here for the tabulated case. So we already know that equation. So that is nothing but for tabulated case dy by dx at x equal to x0. I'm talking about x equal to x0. So this will be equal to 1 by h times 1 by h times delta y0 minus 1 by 2 delta y0 square plus 1 by 3 delta cube, sorry, yeah, delta cube. So delta square, this is delta square y0. And then we are having the next term, fourth term, that is 1 by 4 delta raised to 4 y0. So this much of term, or in general it is going. So in this particular case, in the previous case, we will be having up to this delta raised to 4. Anyway, so this is the general term. So we have to write a program for this particular equation dy by dx at x equal to 0, which means that for the tabulated point. So the algorithm will be like this. First, we have to define a function that is difference function. We name it as difference to return first difference of list. So you have given the y list like in the previous case. In the previous case, I don't know what is that 0, 1, 5, 6, 8. These are the y values in the previous calculation. Okay. So in this given set, if you want to find out what is the difference between these two, first second y value minus first y value. So that we have to calculate. Each time you have to calculate the difference between this y. That will give you delta y0, right? So for that, you are defining this as your function difference to return the first difference of the list, first difference of this list. It means that you have to subtract this, you have to take the difference between each of these elements in this list, y. Okay, let's consider this as capital. And so for that, after that, we have to find number of items in y and store it as n. Number of items in y, this one, and store it as n. Then create a null list of d. After that, we have to create a null list d. So to store the difference. So each time when you calculate these differences, you have to store it in a null list d. So we have to define it like this, something like this, d equal to null list. And you have to store these values of these differences. So first difference will be having 4 values that you have to store in this d. And next time it will become 3 that you have to store in the next time you have to store in the d, and so on. So you have to store the difference in this list d. For that purpose, we have to introduce this d as a null list. Then using formula, calculate ith difference yi plus 1 minus yi. That is this is the first y value, sorry, second y value, this minus this one. That is what mean by yi plus 1 minus yi. That is the difference. So that we have to calculate, then append that value to this empty list D and return that value D, that list, into the function difference. So this function will be having value which is equal to the list value. Okay, so that is for this particular part is just for to calculate this that D difference. Okay, after first we have defined the function, and that function is used to calculate the difference, and that difference will be stored in this list D, and that is returned to the function. Now you have to provide x and y values. Okay, get the x values and store it as a capital X list, and then get the y values and store it as a list with the capital Y, and then find the number of items in that particular list, which means total number of values that is available in that data set, and then we have to calculate what is the h value by using x1 minus x0 equation. Okay, then create a variable diff to represent differential and initialize as 0. So first we have to define or create this particular variable to represent the differentiation or differential, and we will initialize that with the value 0. So difference diff equal to 0 initially. So initialize it with 0. So this diff is to get the value of differentiation. So I'm just giving some variable name. Okay. So after that we have to use a loop to calculate the ith term. Okay, and then calculate the difference of those ith term, and then you have to store in another as D, capital D, after calculating the uh, using after calculating the difference, and store the D, store it as D. Difference you have to store it as D, and replace Y with the difference. Okay, replace the Y with the difference, and then calculate the ith term, and we have to calculate the ith term. So remember that in each time when you consider this D, that will be replaced, that is going to replace your Y values. Okay, each time it will be replaced. So that's why we are giving here replace Y with the difference, that function. Okay, so we have to calculate the difference, difference means that function, and we have to store it as D. Okay, now what you have to do? Now you have to calculate the ith term using the formula Ti equal to minus 1. So this is like Ti equal to minus 1 raised to I plus 1 d of 0 by I. So why we need this particular formula? As you can see from this equation, for the tabulated a differentiation of the tabulated value at x equal to x0, you can consider. For that case, you can see this equation. So in this equation, you can see we have the first difference delta y0 and divided by 1, that is my first I value. Then delta square y0 divided by 2, that is my second I value. Then delta cube y0 by 3, that is my third I value. So each time what I am doing, I am considering the differentiation D. Okay, I think we have made this small d. Okay, you can consider that. So d of 0. Each time we have to consider d of 0. So when you consider first time, I will explain that in program, then you'll be able to understand that more clearly. So d of 0, each time you have to consider d of 0 and divided by I. That is what you are doing here. So first value d of 0 by 1, the next one d of 0 by 2, d of 0 by 3, like that you have to calculate in this bracket. Okay, whatever it is coming in this bracket. Along with that, you have to consider these signs of each terms. For to get the signs, you have to, you can see this is first one is plus, second one is minus, then again plus, then again it is going to become minus. I think it should be 1 by 4th. Yeah, this one has to be minus. Okay, so you check that whether it is written as minus. Okay, so this is minus. So first one is plus, then minus, then plus, then minus. To get that kind of variation in the sign, for that we have added this minus 1 raised to I plus 1. So when I equal to 0, this will become minus 1. When I equal to 1, this will become squared. So this will become, sorry, when I equal to 0, it will become plus 1. When that will become I equal to 1, this will become squared, right? And in that case, this will become positive. Yeah, that is right. Because we have to initialize that with I equal to 1. We cannot consider I equal to 0. So this will be starting when we discuss the program section, we will understand that. So I equal to 1, we have to start. So in that case, this will become 2, so that this term will be squared and first term will become positive, and second time when I equal to 2, it will become 3, so that you will get minus 1. So this will become negative. So in that way, you can change the sign of each of the term inside the bracket, that is written inside the bracket. And after that, we have to multiply all those ti values. First, we have to add all those ti value with the diff value that is initialized with 0. And after that, you have to divide that with h, replace d with d by h, and then print the result. We have to print the result. I think this has to be a difference. Okay, let me see that in the program. I think we have to consider that also as a difference. Okay, so in here also we have to consider it as difference. So this one has to be diff. I don't know this cursor. Okay, so this has to be difference. Diff. This also diff. Okay, so that one, this one we have to divide that with h. Then only you will get that equation, right? And finally, you have to print the result. That is nothing but differentiation. So we have to divide finally with h here. So this bracket term, that is the diff value, and you have to divide this with h and store it as again diff. Then you have to print the differentiation. That is the last step. Okay. So let us consider the program, then you will understand these steps. Just copy these steps, then consider the program. So I will just close this window and go to the next window so that you can see the program. I will just share the next one. So the code, I think code is there. You can see the code in this window. You have already written the code here. So you can see here, the first one, we are defining the function difference. Okay. And for that difference, we have to provide this n value. N is nothing but length of y. Okay. You will understand that why we have to give this. Okay. Otherwise, we can start from here. Okay. So x equal to list of eval function we already discussed. It will give you whatever we have given here, the corresponding data type. If you are giving float value, then it will directly take it as float. If it is integer value, it will directly take it as integer for this x list. Okay, so we don't have to provide int or float or anything like that. Whatever you are giving, entering in this section as input, that will directly take it as integer or float or whatever it is. Okay, so first we have to define this X list where you have to provide the X values. Then you have to provide the Y list. So this list you can see you have to give input and in that input all those values you have to separate by comma. So that will be considered as your Y values, Y data points. And then you have to consider what is the length of X, which means that number. Okay, for example, if you have given 0 to 5, then or if you are giving 1 to 5 in the given example, then it is length will be up to 5. So if it is varying from 1 to 5, it is up to 5. It is varying from 0. If you are considering I value from 0 to 0, then it is going up to 4. Okay, so the length of the x, ln of x will be in the given example, it will be 4 if you are considering indexing from 0. Okay, so so you have to calculate what is the length of x. So you will be having 5 data points basically. You'll be having 5 data points in that particular case in the given example. And then you have to calculate what is h. H is nothing but x1 minus x0. Okay, x1 minus x0. First, second value of x minus first value of x. That will give you h. That is the interval of the given data point. And then we have initialized diff as 0. That is your differentiation value, which is equal to 0. Then you can see this for loop, that is for I in range 1 comma n. For I in range 1 comma n. So we are considering I value from 1, okay, up to n. What is n? N is the length of x. So up to, in this case, up to 4 we have to consider, right? From 1 to 4. Now you have to calculate what is the difference. Difference means what is this difference? Difference is function. It is not a something you have to subtract. No, it is nothing but a function. Difference is function. Where this function is defined, this function is defined here. You can give any name for this function. I have just given difference. If you are getting confused, you can give some other name. Basically, it will calculate the difference between the y values. Whatever we are calculating as delta y0, del square y0, all those things that will be performed by this function. So what this will difference? So when it reaches at this step, our I value is equal to 1. I value is 1. So then it will go to this step and it will calculate what is the difference of y now. So what is y? Y is the given list, this list. So in that list, it will from that list, it will calculate what is this. The difference of y, it will go. And in that difference of y, first it will calculate what is n, small n, that is length of small y, length of small. So the length of this y, that will be this length of this y, because it is taken directly that function. And that will be calculated. What is the length? So the length will be, so the values are have 5 values, okay? So up to 4. So we have to vary from the I value. I value should be varying from, so okay. So then we have to initialize this d, small d, which is equal to an empty list. This small d is equivalent to an empty list. And that small d equal to an empty list will be used to get the difference values. Okay. So in this section, for I in range n minus 1, so for example, I equal to 0, for I equal to 0, to n minus 1, whatever the length that you are giving for this y data, depending on that, this loop will run. So initially, I will be equal to 0. So for that case, d dot append y of I plus 1 minus y of I. What is I? I equal to 0. So this is y of 1 minus y of 0. Whatever it is in this given value of y that is given in this list, that value will be subtracted from each other. That is, first we have to consider y of y I plus 1, which means that y1 for I equal to 0 and minus y0. So that is the first difference. Then for the next, that value will be okay, that will be continued. Okay, so d dot append this value, so which means that this empty list will be appended by these values, which means that first one will be y of 1 minus y of 0, and then again it will check whether this condition is reached or not. So next time I will become 2. Okay, whether it is in the range n minus up to n minus 1. Yeah, so this n is the length, that is nothing but 5 in this case, which means 5 data points are there. So it is n minus 1 is 4. So I will become 2. Sorry, I will become 1 next time. So that it will become, this will become y of 2 minus y of 1. Okay. And it will run again, and it will go to this, it will append to this list. So the second value will be appended. And again it will check whether I has reached to its limit. No, it is not yet reached to the limit. So then I will become 3. Again it will go to this step. Now it will calculate y of 3 minus y of 2. Okay, and so on. Sorry, I equal to 3. Sorry, I equal to 2 in this case, and it will be calculated y of 3 minus y of 2. So each time it will calculate the difference, and when I will become 4, it is going to reach to this n minus 1, because n is 5, so n minus 1 is 4. Then it will exit this particular for loop, and in that moment your d will be appended with the 4 values. Okay, that is y1 minus y0, y2 minus y1, y3 minus y2, and y4 minus y3. When I equal to 3, this will become y4 and minus y3. So that much of difference will be appended to this empty list d. Okay. Okay, so after appending those values from this step, we have gone to that particular function. After appending all those values, then it will return to, all those value will be returned to this function difference. Okay, then you have to give that value to this capital D here. That is the that is what we have written here. D equal to difference of y. Okay, so this is for I when I equal to 1. We have provided I value from 1 to n. So this time this I will be equal to 1. And then this y will be taken values of this d. So now your y will become the difference values. Okay, so that is the delta y0 values. Delta y0 values in that column. Okay, and then ti will be equal to minus 1 to the power I plus 1, that we already discussed how it is coming. D of 0 by I. That is the term inside that bracket. Okay, this will be taking care of that sign, and this is the d0 values. So in this case it will be, what is this d0? This d0 is the first value in this list, capital D, first value in this list. What is that list? Whatever you are having value in this small d. So that is first value. So that is the value of delta y0 that we are considering. Then difference will be equal to difference plus ti. Difference we have given as 0. The difference will be difference plus ti. Okay, and then we'll go to the difference plus difference equal to difference by h. So before that we have to complete this loop. So difference is difference plus ti. So difference initially which is 0 plus ti. Ti is nothing but this quantity. So this time it is minus 1 to the power I equal to 1. So this will become positive. So it is nothing but d of 0 by 1. That is del of 0. Delta of 0, delta of y0. So delta y0 we calculated in the first case when I equal to 1. Then when I equal to 2, again it will check whether it is still in this range. Yeah, 2 is 2, it is 2. It is up to capital N. Capital N is 5, right? So it is going to up to 5. So I equal to 2 now. Next for it, next iteration. Again it will check what is D. D equal to difference of Y. Now your capital Y is the difference values. Okay, not this values. Your capital Y is not this values now. Now your capital Y is replaced with this D, right? So it is nothing but delta Y0 values in that column. So again, it will go to this function difference of y, and again it will check length of y. Length of y, now it will become 4 because you are having only 4 data points for difference. You have taken y1 minus y0, y3 minus y2 minus y1, y3 minus y2, all those values. Then you will be getting 4 values for that difference. So that will be stored in this D, and that is your y now. Okay, so again it will calculate, it will initialize with this small d as an empty list, and it will go from I to n minus 1. So up to 3 it will go, I value from 0 to 3. So it will again run, and you will be getting the next set of differences for the delta square y0. Okay, delta square y0 column, you will get all those values, and that will be taken as capital D, and again it will be replaced with the capital Y. So this capital Y will be, sorry, this capital Y will be replaced with this capital D. That is the second difference, delta square y0 values in that column that we have just performed as an example. Okay, again it will go to the next for this calculation. So here it will be considering I equal to 2. So this total term will become 3. So that this will become minus quantity. And what is D0 now? D0, your D0 now is the first element in this D list. What is that? It is the delta square y0, first element in that column. And this one you can calculate, and in denominator will be getting 2 because I value is 2 now. And then you have to add that value with your previous differentiation value. That is the value of delta y0. Okay, so that has to be added with delta square y0 by 2 with a minus sign. So minus delta square y0. So this one is now delta y0 minus this ti is minus delta square y0 by 2. Okay, and similarly it will run for the other values, and you can get the dy by dx at x equal to x0, that equation. And finally you have to divide that entire differentiation value that is in that bracket in the equation by h, so that you will get the differential of that particular value. So if you run this particular equation. So this is a case when you are considering tabulated value. Okay, so that we didn't do in the example. We have taken an arbitrary point 1.2, which is not tabulated point. So in this case, I will just use the same points, but the initial points I have to consider to find out what is the dy by dx in this particular case, because we are calculating for x equal to x0. So let us consider the same values for this y 1, 5, 6, 8. But for this, I have to use, I will be getting the dy by dx at x equal to x0 only, because the program is for that particular case. And if you want to get the program for the other one in general case, then I will just modify this program as like this. I will just copy that one here. We'll just modify that program. So this is same. The difference comes in this step. Also, I have given one more step here, one more instruction here. V equal to any variable you can give. So I have just given V equal to eval input enter the point where df by dx or dy by dx. You can give dy by dx, no problem with that. Where the dy by dx to be determined. So this is a general case. If you want to find out dy by dx at any point, then you have to use this program. So I have given as eval input enter the point where dy by dx is to be determined. That we have to provide. Okay, so, but in this case, when you calculated this one, you are calculating the differentiation dy by dx at x equal to x0, which means at the initial point. But here we can calculate at any point, and that point you have to provide. And if you are considering such a situation, then you have to calculate what is u value. U is nothing but the x that you this particular value where you have to calculate the dy by dx minus x0 by h, that is x minus x0 by h. Okay, that is sorry, that is u that I have already given here. So this is an additional line, and then all other lines are same, but here we have to multiply with some constants. So when you calculate ti, we have to calculate ti as d of 0. Okay, ti equal to d of 0, that is the first element in this difference. So delta, for example, delta y0 will come first, and then I have to check whether I equal to 2. I equivalent to 2? No, because first we have to consider I equal to 1. So when I equal to 1, it will not go to these steps. I equal to whether I equal to 2, whether I equal to 3, it will check each time. Whether if I equal to 4, no. All these conditions are failed, so that your differentiation will be equal to differentiation plus Ti. What is Ti? Ti is my D0. What is D0 when I equal to 1? What is D0? D0 will be first element of this list, that is nothing but delta Y0. Okay, and next time when I will become 2, when I will become 2, it will be again considering ti equal to d of 0. Now it is taking the first element in the delta square y0 list. Okay, so that is nothing but delta square y0, delta square y list, which is nothing but delta square y0, and that is that will be checked with these conditions that I have given additionally. So if I equivalent to 2, now I equivalent to 2, so that your ti will become ti star. It is no longer d of 0. It has to be multiplied with the additional constants 2u minus 1 by 2. That is the coefficient that is associated with the delta square y0 term. You can check that with that equation. So you have to multiply 2u minus 1 by 2 with that particular delta square y0 value. Again, it will check if I equivalent to 3. So if you want to get the steps reduced, you can shift these things to this side. Okay, so that it will come inside that. Otherwise, you can give else if condition here. If it is checking this one first, if it is not only, you have to check this one. That also possible. I am just giving some instruction. Okay, so this is just to understand. So you can give else if statement ladder structure you can give. That is also possible. Okay, so let us consider. So again, it will check all these conditions. So if you are using if else conditions, then you don't have to check all this every time when you run the program, so you can reduce the steps. Okay, anyway, so it will check this when you consider this program, and you can see I is not equal to 3, I is not equal to 4 here also. So it will directly go to this step differentiation equal to initial differentiation plus ti. Now it is ti is 2u minus 1 by 2 times ti of that is 2u minus 1 times by 2 times delta square y0. That is your ti now. That will be added with the previous differentiation value, that is nothing but delta y0. Okay, similarly, it will continue this loop for I equal to 3 case. It will not go to this step. Okay, this step will not go. It will go to this step, and you will be multiplied, that particular delta cube y0 will be multiplied with this term 3u square minus 6u plus 2 by 6. So you can rearrange the program like this for the general case, and this is only up to delta raised to 4 y0. Okay, so if you want additional terms, for example, if you want to 10 up to 10 terms, if you want to do this, then you have to consider up to that term, and you can reduce the program by analyzing these particular coefficients, and you can use some if it is possible, you can use some loop for that also. Okay, I'm just giving you some hint. Okay, so this is the program for up to delta raised to 4. We can calculate. So I will just run this program and show you the result that we have got in the calculations that we have done theoretically, which is same as by using this the program. So I will use the same x values 1, 2, 3, 4, 5, and y values 0, 0, comma 1, comma 5, comma 6, comma 8 that we have used to calculate. Okay, so then it will ask me enter the point where dy by dx to be determined. This was not there in the previous program because we were calculating dy by dx at x equal to x0. So this I have to give 1.2, that is the point that we have calculated dy by dx for the given data theoretically, right? So if I press 1.2, you can see minus 1.77333. So this is the almost approximated value that we have got for the same problem theoretically. Okay, so this is the Newton's difference method to calculate the differentiation numerically. In the same way, you can also consider the second order differentiation also. For that, you have to use that particular equation. Okay, so that's all. I think it is this one is okay. If you want, you can just. I think this will be fine. I think I hope you understood this program. Maybe okay. That's enough, I think. And if you have any doubt, you can check it further, and can see any. If you are having any difficulty, you can ask that particular part.